Morning, everyone. Afternoon, everyone. Evening, everyone. I'm not sure what time you're watching this because I'm not quite sure when it will go up. I'm now, I think, 9 hours ahead of you in Japan. I'm in Kyoto, but I thought I would make time to do this very quick one on Banbury case study and hydrographs as requested. So, the simple one with Banbury is basically you're looking at how rivers flood, how they're managed, and Banbury is just a case study of that. Banbury is a place in southeast England, not far from Oxford, between Oxford and London, and you're expected to know specifically how they dealt with flooding, how they have managed against it successfully and also unsuccessfully too. Okay, so in terms of flooding, obviously it's a little market town, and in terms of flooding, it floods quite frequently. The UK obviously experiences quite high rain during the winter months, and that can cause flooding in its own right, of course, and obviously the banks can overflow. So in terms of management, what Banbury's done, and you can split this up into different categories if you'd like to, is that roads have been built higher up. So that is kind of reducing the risk of flooding. Not 1,000,000% reducing the risk, but reducing it from what it would be. They've also built embankments and flood walls that have high expenses, but are quite sturdy and last a long time. And they've also constructed outside businesses and houses of importance away from the area. They've also introduced a pumping station, and that's what they've built to basically remove the water from the town. They've also introduced wildlife and vegetation either side of the river, because don't forget that means these surfaces are more permeable. And they've also increased flood water storage, the amount of flood water that could be stored. It can now hold up to 1,200 Olympic swimming pools full of flood water. And the gates can be closed if the weather shows there's going to be high rainfall, for example. In terms of benefits and costs, I'd always just remember these on a little flashcard, and I would definitely split them up into social, environmental, and economic. So in terms of social, it's about houses being uninsured potentially, and people are no longer worried about flooding in their houses because things have been done to stop it. And they also have new footpaths, new parks, new places to go. That improves their quality of life. Environmentally, it has helped as well because there's a new biodiversity action plan. However, there are negative costs for the environment too, with heavy machinery being used during construction, and soil was removed for the embankment, so therefore habitats were destroyed in some way. It did cost £18.5 million, so that is kind of an economic cost, but as a benefit it created jobs for people too. So that means they had an income, they pay tax, positive multiplier effect, etc. In terms of hydrographs, very quickly, I mentioned this in the previous video. So you have ultimately a flood is on a flood hydrograph. So over time, the x-axis, and y is the peak discharge and the peak rainfall. So the little bars are rainfall, the line is the water level in the river effectively. So the higher that goes, the more there is a flood, the more the river floods. So it starts here, that's the rising limb, it goes up, reaches the peak discharge, and then falls back down. The thinner the hydrograph, so the steeper the curves, the steeper the rising and falling limb, the quicker a flood event happened. Often the more severe, the more flashy, the less warning you get. The more gradual a flood, then that's not often a subdued flood, happened over a longer period of time. If you have areas that are urbanized, it's going to be more flashy. If you have areas that are forest, more subdued most of the time. Any questions, let me know. See you soon.